Good morning, students. This is Anjali, Assistant Professor, Department of CAC, AIML, IARE, Hyderabad. Today's our topic name is correlation versus causation. In previous class, we have seen about data visualization. In data visualization, we have used so many graphs. That means by using so many graphs, we can data visualize a data for our use, for the uses of the users. That means we have used here the bar chart, we have used the box plot, we have used scatter plot, then again line chart, histogram. All these things are very useful, and every chart is used for some purpose. Every chart, bar chart we can use, in bar chart we can use so many bars, like vertical bar chart, vertical, horizontal, then stacked, then another one is a stacked group. All these things are types of the bar chart. And then after that we have seen again box plot. Then box plot can contain the some whiskers, upper lower, upper point, then lower point, then again sometimes there will be available the outliers also. And we will plot our box plot by using the median, by finding the median point. Then after that we have seen the some scatter plot. How to draw the scatter plot? That means by using there are some x-axis and the y-axis. By using some coordinates, we can plot the scatter plot. Then line chart we have seen. In line chart, we can draw so many, that means multiple line chart is available and single line chart is available. Single line chart is very easy to understand and it is very easy to analyze. But if we are using so many lines, that means if we are using the multiple line chart, so at that time it can become confusing graph. So we can use only till 4 lines in line chart, so it will be very easy. But if you use the more than 4 lines, so it will be very confusing for you to understand and to analyze any pattern. Then after that we have seen that the histogram. Again histogram also is like a bar chart, but so that histogram will not contain any gaps between the bars. So this is all about the data visualization. That means we can visualize the data by using the different charts, different types of the graphs. Now today we will start our topics, that is correlation versus causation. So our contents are introduction, correlation, types of correlation coefficient, then causation, and difference between the causation and correlation. Now we will see one by one. First one is introduction. Actually, correlation and causation, both concepts are related to data and the statistical analysis. Definitely, when we are talking about the statistical foundation of data science, at that time, there will be available some types of the data, different types of data. We are analyzing the data, we are fetching data from different sources, and we will need to correlate our data. That's why we can say that the correlation and causations are different concepts and which are totally related to your subject, totally related to statistical analysis. And both these topics are describing the relation between the two variables and help determine whether there is a relationship at all. That means they will describe that if there is a relationship, then it will describe, and if even it will check that is there any relationship between the variables or not. Then after that, those whose jobs involves research and analyzing relationships might often work to measure one or establish the other. So this data, even this correlation and causations, both are involving in the some researching job. So we can analyze the relationship between the variables, and we can measure and we can establish the some output some data also. And the correlation and causation generally describe the relationship between the two variables. This statement is a very important, that the correlation and causation describing the relation between the two variables. Now, however, while one, that means we can say that the correlation describe how variables are associated, and other concept, that means we can say that the causation is concerned with how one variable might affect another. That means correlation and causation, already I said that the correlation and causation both concept are different. Both concepts are very useful, and the correlation will describe your variables, how they are associated with each other, and causation will describe that how your variable will affect on another variable. And for example, the person starts a new job as a part-time worker, and after 6 months receives a promotion to full-time status. The variables are salary and the employment status. That means we can say that person has started a new job as a part-time worker, but after 6 months he got the promotion, and his or her status has changed. That means from part-time to full-time. Now we have got the two variables. That two variables are the salary, and another variable is the employment status. And these two variables correlate to one another in that the worker earns a certain pay based on their position with the company. The change in the employee's employment status from part-time to full-time, however, also create a causal relationship, as the employee's salary goes up based on their new full-time employment. Definitely, first that person was working as a part-time worker, but after some months, his status has changed from part-time to full-time. And so that means employment status has totally changed. And then, on this basis, definitely when one of the person is working in some organization, there will be some casual relationship between the clients and that particular employee. So that employee's salary can be changed. It will be changed as per your full-time employment. That means as per the status. So here we can say these things are totally related to each other. These things are totally related to each other, and it will affect also some points. So now we will see what is the correlation. It means correlation refers to the statistical relationship between the two entities. That we can say that it will show the statistical relationship between two entities, two variables, and it measures the extent to which two variables are linearly related. These two variables, whatever you are using the variables, whatever variables you have used, all these variables, both these variables will relate each other. For example, we can see the height and weight of the person are related, and taller people tend to heavier than the shorter people. So in the correlation, we can say that height and weight, both variables are related with each other, and we can say that taller people is heavier than the shorter people. So you can apply the correlation to a variety of the sets, and in some cases you may be able to predict how things will relate, while in others the relation will come as a complete surprise. That means when these two variables here, when we are comparing height and weight, so both things are related with each other, and totally these variables are very useful here, and by using this variable totally it will affect on the different data sets, and we can predict that how these things will relate each other. And on this basis we can get some surprise results. And it's important to remember that just because something is correlated doesn't mean it's a causal. It's not like that. If there is a relation between two variables, that means it will affect on each other. It's not necessary. So just now we are talking about the correlation. So there are different types of the correlation. First is a positive correlation. The positive correlation is when variables move in the same direction on a graph, indicating some sort of dependence between the two. Actually, your positive correlation is showing that whatever variables are available in your data set, those variables will move in the same direction, and that will indicate that the dependency of the variables. For example, there is a positive correlation between the amount of time someone spends driving in a direction and how close they get to their destination. This is your positive correlation. So your variables are moving in the same direction, and this is the best example. Amount of time you are spending on driving in the direction and how close now you are to your destination. So after that, there is a negative correlation. The negative correlation means when two variables move in opposite direction on a graph, we can say that inverse relationship. In positive correlation, what happened? All variables are moving in one direction. But in negative correlation, all variables will move in the opposite direction. That means some variables will move in downward direction, some variable will move upward direction. For example, a car in the middle of the rush, our Causation decreases its speed, causing the time it will take to reach the destination to increase. So this is the best example of the negative correlation. After that, zero or no correlation. Zero or no correlation occurs when there is not relationship between the two variables. For example, a car that's low on gasoline experiences a glitch in its sound system. That means there is a zero correlation, though as a feeling a car's tank won't fix what's wrong with the car's speaker. So it will not affect each other. They are not correlating it with each other. That's why we can say that there is a zero correlation. There is zero correlation. There are three types of correlation. First one is the positive correlation, then negative correlation, and next one is a no correlation. In positive correlation, your variables move in the same direction. In negative correlation, variables will move opposite direction. And in no correlation, it will not show no relation between the variable. Now we will see the example of the correlation. Some real life examples are there. So we will see one by one. First one example is body fat and the running time. An individual's body fat tends to be lower the more time they spend jogging. That means we can say that there is a negative correlation between the variable body fat and the variable running time. We have two variables. One is a body fat and another variable is a running time. So both variables are running in opposite direction. That's why we can say there is a negative correlation. Body fat decreases as a running time increases. Then after that, exam results and TV viewing time. Exam results typically suffer when a student watches more television. In other words, we can say there is also negative correlation between the variable amount of time spent watching a TV and the variable exam grade. These two are variable for us. That means exam results decline as the TV viewing time increases. If you will watch TV for more time, for much time, so at that time definitely your result will get decrease. Then third example is that height versus weight. The relationship between a person's weight and a height is often good. To put it another way, bigger people often weigh more. The fourth example is that temperature versus sales of ice cream. The temperature and overall ice cream sales have a favorable association. That means we can say in other words, more people like to buy ice cream when it's hot outdoor. The company's overall ice cream sales tend to be greater when it's hotter outside. So these are showing some negative correlations. That means one of the variable is decreasing and another variable is increasing. And if first variable is increasing, another variable will be decreased. Then after that, what is correlation coefficient? The correlation coefficient gives you the measure of the strength of the linear relationship between two variables. The letter R denotes the value and it ranges between -1 and +1. If R less than 0, it implies the negative correlation. If your R is greater than 0, it implies the positive relation. And if your R value is equal to 0, that means it implies no correlation. So, calculating the correlation coefficient will take time. Therefore, data entered into the calculator computer statistic program for calculating the correlation coefficient. So, this correlation coefficient will show some of the strength of the linear relationship. That means it is showing the relationship between the two variables, and for that we are using the letter R for denoting the value, and that it will show the ranges like -1 to 1. If your R is less than 0, then that means it is the negative correlation. Your R is greater than 0, it is a positive correlation. And if your R is equal to 0, that means it will show the no relation. Now there are different types of correlation coefficient. There are mainly two types of correlation coefficient. Pearson's product moment correlation. The Pearson correlation coefficient is defined in statistics, the measurement of the strength of the relationship between two variables and their association, and it is denoted by the R. The correlation coefficient can be calculated by using the formula that R is summation of xi minus x into yi minus y bar divided by square root of summation of xi minus x bar whole square into yi minus y bar whole square. So here R is showing the coefficient of the correlation, x bar is showing the mean of the x variable, y bar is showing mean of the y variable, and xi yi is showing the samples of the variable x and y. Now Pearson's rank correlation. The Pearson's rank correlation measure the strength and the direction of association between two ranked variables, and it basically gives the measure monotonicity of the relation between the two variables. How well the relationship between the two variables could be represented using a monotonic function, and for that we will use one of the formula. That means Spearman rank correlation is equal to 1 minus sigma summation di square divided by n into n square minus 1. So this formula is showing the Spearman rank correlation. Then di is showing the difference between the ranks of corresponding variables, and n is showing the number of observations. Then that means this is all about the correlation. Now we will see the causation. Causation refers to a relationship between the two variables or events where one variable has an effect on the other. And the causation is when one variable causes a change in another variable. That means when we will talk about the causation, so at that time one variable will affect on another variable. So when some of the changes will be occur in first variable, then automatically there will be some changes in the second variable. So for that we will take one of the example. The job promotion in the first example caused the salary of the employee to increase. So when we spoke in the first topic in the introduction, so at that time we have taken the one of the example, that person job status has changed. That means from part-time worker to full-time worker. At that time he got the promotion and his status totally got changed. So it affects on the salary also. That means that job promotion caused the salary of that employee, and that salary also it increased. So totally it affects on the salary. For determining whether one variable causes another to change, it's important to design and conduct an appropriate experiment. A successful experiment typically tracks each variable while also excluding other variables that might interfere. Now we will take one of the example. There are four main criteria for causality. First one is the covariation, then non-spuriousness, then plausibility, and temporality. Covariation is showing that the variables can be vary together. Then non-spuriousness will show, it is showing the association between the variables must not be due to the third or confined variable. Then plausibility, the claim of the causation must be plausible and must therefore make sense. And the temporality showing the cause must take place before the effect. The causation between random variables A and B implies that A and B have cause and the effect relationship with one another. So first topic was the correlation and another one is the causation. That means first will be the cause, and because of that cause it will affect on the another variable, or we can say existence of one gives birth to the other. So we say that A causes B or B causes A. Causation is also termed as the causality. So correlation and the causation can exist at the same time also. So definitely correlation doesn't imply causation. There are some example. So run out of the battery. This is causation. Causation, it's run out the battery, computer shuts, and again video player won't work. That means causation, it is showing the causation between the, if run out the battery, your computer can get shut up. Then if, or we can say video player won't work also. So this is the causation, and computer shuts and the video player won't work. These are the correlation. So no battery in computer causes computer to shut, and it will cause that video player to stop. Shows that causality of the battery over laptop and video player. And the moment of the computer shut, video player also shuts, shows both are correlated. That means at the same time we can observe the correlation also and the causation also, and more specifically positively correlated. Now there is one of the example to determine whether there is a causation between the time web visitors spend on the web page and the type of the content that follows an article. Company runs an A/B test where only half of the readers see featured content. Following the test, company does a session analysis to see whether there was any difference between the two groups as far as time spent on the web page or site overall. Now, how to establish the causality, and for this we will use the three conditions. First condition is that the temporary precedence, another one is the empirical association, and third one is non-spuriousness. First one is a temporal precedence. The cause must precede the effect. That means that cause is your independent variable and the effect will be the dependent variable. Then second one is the empirical association. There must be observed correlation between the two variables. Then third one is the non-spuriousness. The observed correlation between two variables cannot be due to the third or outside variable. And each of these condition is equally important. Every condition is very important. Temporal precedence, empirical association and the non-spuriousness. Every condition should satisfy. And if anyone is not met, then there is not the causal relationship. For causal relationship, there is must to meet these conditions. As for non-spuriousness, if third variable influences a change in the other two variable, then this is an example of correlation does not imply the causation. Now, correlation does not imply causation. There are again some conditions. As noted, correlation does not imply the causation because there could be third variable in the relationship. If in that relationship there is available the third variable, then definitely there will be no the correlation. Further, finding out the two variable correlate does not provide any evidence for knowing what was the cause of either. For example, the employee's promotion in addition getting a raise and employee is also moving from current office to new one in different building. That means this is showing the cause also and correlation also. Though there is a correlation between higher salary and the new office, one does not cause the other. For both development, the cause was the third variable. That the third variable is the promotion. Now deriving the causal relationship. How we will derive the causal relationship? Let's we see. First one is the experimental data. The most effective way to derive cause and effect relationship is through use of randomized experimental data. Here you have to use randomized experimental data, and in this method, random assignment is used to separate subjects into control group and treatment group to study the effects of the manipulation of the independent variable by comparing both groups. Then after that, first one was experimental data, second one is the observational data. That means in experimental data, you have to do some treatment, you have to do some experiment. After that, you can get the relation and relationship between the variables, and you can get some variables also, independent variable. Then next, second one is the observational data. In cases where randomized experimental data is unethical or impossible to obtain, observational data is used. Such data is generally extracted from existing data sources due to which there is an absence of random assignment and control. It is harder to conclusively derive a causal relationship between the variable using observational data, as the variables cannot be controlled or assigned into different groups through the randomization. Then there are some examples of the causation. First one is the price and demand. That means we are using the law of the demand. In study of economics, the law of demand explains that the demand and the price have negative causal relationship, where price is the independent variable and demand is the dependent variable. When price increases, it influences the decrease in the demand, and when price is decreasing, the demand is increasing. So both are affecting each other. Then second one is the caloric intake and the weight. In this relationship, caloric intake is independent variable and weight is a dependent variable. So increase in person's caloric intake leads to increase their weight, and if calorie intake is less, then definitely weight will also decrease. These two variables have a positive causal relationship as both variables move in the same direction. In this example, both variables are moving in opposite direction, and that's why this is the negative causation is showing. Here positive causation is showing. Now there are some 5 ways to test the correlation versus the causation. First one is the randomized and experimental study. There is where you randomly assign people to test experimental group. In experimental design, there is a control group and an experimental, both with identical conditions but with one independent variable being tested. By assigning people randomly to test experimental group, you avoid experimental bias where certain outcomes are favored over the others. Then second one is a CASI experimental study. This is when you can't randomize the process of the selecting users to take the study, and this typically require more advanced statistical procedure like survey, interviews and observational notes to get the necessary insights. Then third one is the correlational study. In this, when you want to try to determine whether two variables are correlated or not, at that time you can use the correlational study. And the correlational study is when you try to determine whether two variables are correlated or not. That means if A increases, then B will also increase. That is the correlation. Just remember that correlation doesn't imply causation and you will be alright. For example, you decide you want to test whether smoother UX has a strong positive correlation with better app store ratings, and after observation, you see that when one increases, the other does too. You are not saying A, that means we can say smooth UX causes a B, that is a better ratings. You are saying A is strongly associated with the B, and that means it is showing the correlation between the A and B, and perhaps might even predict it. That's the correlation. Next one is a single subject study. In single subject study, instead of control and experimental group, a single subject serves as his or her own control. The researcher is concerned about the attempting to change the individual's behavior or thinking. Since it's hard to assume the actions of one individual reflect those of large group, this study is rarely used in the marketing. Then next one is the stories. Anecdotes sadly are sometimes all the proof we have to establish the causation you might come across. First one, support staff. Support staff, that means customer will think the new user interface is tough to use. That's why they are uninstalling. Then second one, customer X on Twitter. Then we tried to buy product on your app and it's making my phone crash. Then the problem here is, while they could have a valid pain point and might make it in the convincing manner, these stories do not prove without a doubt that A causes B. They are really just stories at this point and carry less weight than the other option above. Now we will see the difference between the causation and the correlation. Causation is showing that the warmer weather caused more sales of ice creams. And the correlation is showing the weather gets warmer with increase in sales of the ice cream. Then second one is the too many steps in the purchasing on an app leads to cart abandoned and also uninstalling the app. Then correlation is showing that cart abandonment means more people uninstalling the app. Then causation, smokers like to drink coffee and the smokers develop lung cancer. And the correlation is showing that coffee drinkers are at high risk of lung cancer. And the causation is showing that stress causes the depression, and correlation is showing that stress causes the rumination, which causes depression. So this is all about the causation and correlation. These are your references. So you can go through these references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.